Alright, so in this video I'm going to talk you through a few different ways we can think about the multiplication of whole numbers. So the first way I'm going to talk you through is the repeated addition model, which is when we think about multiplication as adding a number to itself a certain number of times. The second way I'm going to talk you through is the array or area model, which is when we think about multiplication as visualizing it as an array or a grid. And the last way I'm going to talk you through multiplication is the Cartesian product model, which is thinking about multiplication as Cartesian products or pairing groups of items together. So, like I mentioned, the repeated addition model can help us see multiplication as just adding the same number to itself a certain number of times. So, if we have 4 groups of 3 brushes, we can use addition to put the groups together. When we put equal sized groups together, we can think about it as multiplication. So this is combining 4 sets of 3 objects into a single set. So this would be 4 groups of 3 is equal to 3 plus 3. 4 times 4 threes gives us 12. Another way to think about the repeated addition model is using some physical models, number tiles or numbered lines, and seeing that 5 groups of 4 is just adding 4 to itself 5 times, or having 5 lengths of 4 combined together. So we can see 5 groups of 4 is just adding 4 5 times, and it would give us 20. Alright, so our formal definition of multiplication of whole numbers using that repeated addition model is that n times a means I'm adding a to itself n times. I also like to think of this with the phrase in groups of a, or of a n times. Alright, so coming back to that array or area model for multiplication, we can see here that 4 times 5 is going to give us 4 rows and 5 columns. In the array, we just have dots designating the different parts of our multiplication, and so those could be like discrete items like desks or playing cards or whatever you wanted to put in this array. An area model is going to give us a better way to look at problems involving area or continuous lengths. So this could be like if I have a classroom that is 4 yards by 5 yards, how many square yards is my classroom? Alright, and then one more way we can think about multiplication is the Cartesian product model. So take this example. Suppose you plan to take 2 online courses at your college. You can take one of the following. You can take world history or ancient history. For your second course, you can take Latin, French, or German. To show the number of different schedules you can have, we can use a tree diagram. So a tree diagram is going to help us think about these two, combining the options that we have between our first class and our second class. And the way that we can design these tree diagrams is by thinking of the classes we can take for history and the classes we can take for our language as 2 different sets. So first, the set of history classes is world history, ancient history, and the set of the classes we can take for foreign language is Latin, French, or German. So what a Cartesian product does is it takes one component from the first set and one component from the second set, and it lists out all of the different combinations that we could have. So for example, the Cartesian product of 2 sets A, B, C, and 1, 2 would be all of the ordered pairs A with 1, A with 2, B with 1, B with 2, C with 1, and C with 2. So So that's what our Cartesian product is doing. We can visualize this with a tree diagram. So in this situation, we can say, all right, first we're going to choose our history class. If I choose world history, then I have 3 options for my language: Latin, German, or French. If I chose ancient history, I also have 3 choices that I could pair with it: Latin, German, or French. So this gives us those ordered pairs of the combinations we could have. So what this culminates in is the fundamental counting principle. It tells us that the total number of ordered pairs that we could get in this Cartesian product of history classes times language classes is 2 times 3 equals 6, because I had 2 options for history, 3 options for language. So for any finite set, if the number of things in the set A is little a, the number of things in set B is little b, then multiplying the number of items in A times the number of items in B will give us the number of items in that Cartesian product of A cross B. And so this is how we define multiplication using that Cartesian product model. Okay, so when we think about the definition of multiplication using this Cartesian product model, essentially sets A and B don't have to be disjoint. They can have things overlapping. The expression A times B, or just AB, is the product of A and B are called factors.